Hi, thank you for being here today. Ladies and gentlemen, welcome to the last Masterclass of 2026, proudly brought to you by BEX Asia in partnership with our various BEX Asia exhibitor. My name is Isabel and I will be your host today. On behalf of the speakers today, we would also like to welcome all the attendees who are joining us from Singapore, Malaysia, Philippines, Japan, and Canada. Before we begin, allow me to tell you a little about BEX Asia and IBEW. BEX Asia is the largest built environment exhibition in Singapore with a solid focus on digitalization, innovation, and sustainability. Our 19th edition this year will take place from 2nd to 4th September at Marina Bay Sands, and we are expecting over 300 exhibitors and more than 10,000 attendees. BEX Asia, of course, runs alongside Southeast Asia's largest built environment conference, the International Built Environmental Week, jointly organized by the Building and Construction Authority and RX Singapore. This year's theme of empowering people, accelerating intelligence will put the focus squarely on topics that are making its impact felt in the industry, namely AI and its use cases in built environment, preparing our talent to be ready for the AI transformation and, of course, sustainability. Happening from 2nd to 4th September, also at Marina Bay Sands. Do make sure you follow our LinkedIn pages to stay updated as we will be launching ticket sales really soon. Speaking of impactful speakers, I'm pleased to kickstart Masterclass titled Building Smarter, Building Greener, Digital and Sustainable Solutions for the Built Environment. Joining us are Ms. Su Hui-Ping, Senior Lecturer from Singapore Polytechnic, Digital Building Innovation Center, and Ms. Jackie Fernandez, Technical Manager at CIAP Architects Private Limited. Let us welcome the ladies to the screen. Hi, Hui-Ping. Hi, Jackie. Thank you for being here. Now, ladies and gentlemen, before we begin, a few housekeeping announcements. This masterclass is scheduled for 1.5 hours and will be done in 2 sections. We will be taking questions at the end of the first section by Ms. Jackie and Ms. Hui-Ping. So you can submit your questions using the Q&A function in Zoom found at the bottom of your screen. With that, let me hand over the masterclasses to the ladies.
Hi everyone, I'm going to start the sharing. So good afternoon, I'm Hui Ping, Senior Lecturer from the Architecture and Built Environment at Singapore Polytechnic. I'm from the Diploma of Architecture course and I teach architectural design, codes and BIM. At the same time, also a consultant with Digital Building and Innovation Center, DBIC for short. So I'm currently assisting the industry with digital transformation in the built environment, in particular for Corner X, where we help to train firms that are new to Corner X in the digital transformation. And here with me today is Jackie from CIAP. She's a technical manager where she supports the firm's digital delivery initiatives. Jackie is also the main personnel driving Corner X in her company. So in today's sharing, CIAP will share their experience on embarking training with SP for Corner X. We welcome all firms new to Corner X as well as teams transitioning to BIM-based submission. At the end of the day, we believe that firms want to be ready and not to react late to this new framework. So CIAP came to us with minimal Corner X knowledge. They were strong in BIM, but they wanted to see how the training for Corner X can be structured within the firm, especially so when their BIM modelers were distributed between Singapore and overseas. So Jackie, as a BIM manager, was tasked to build up the team's expertise in Corner X. So in the beginning, there was some uncertainty on how to kickstart for a Corner X submission. There was some confusion between BIM, IFCSG, and Corner X framework itself. The firm wanted to be well prepared in their submission model and didn't want to risk high submission errors. They also wanted to know the impact of the Corner X framework on the roles of the architects and BIM coordinators within the firm. So SP came in hoping to help them navigate the new digital submission process to align Corner X understanding across the different roles. There was also a need for future proofing of their skills. So what we did was SP came up with a structured, practical training approach to help CIAP navigate towards Corner X submission. So in this collaboration, CIAP came on board with us through the mentorship support grant. In a nutshell, this scheme, how it works is that we first help CIAP to develop a training guide and learning resources for Corner X. After which, an on-the-job training blueprint was developed to outline the job enhancements for the BIM coordinator and manager's role. So this guide was to be used as a train-the-trainer program for the technical manager to carry out the training within the firm, even for human resource hiring, blueprint for BIM coordinator. Lastly, there was mentorship where there was a trainer together with me to visit the office to help CIAP with technical setup and troubleshooting in their preparation of the IFC model for corner extraction. And now I will hand over this sharing to Jackie. She will be sharing her perspective from the company's viewpoint on their training journey with SP.
Good afternoon, everyone. My name is Jackie. Today, I'll be sharing on CIAP's ConnectX journey, our progress to date, and how we have positioned ourselves to be ready for ConnectX. So from the outset, our objective was clear: to build knowledge, systems, and confidence needed ahead of ConnectX mandatory implementation. To achieve this, we adopted a structured onboarding and training approach in collaboration with SP, who has been guiding us step by step towards ConnectX readiness. We kicked off in the third quarter of 2025. At that point, our knowledge of ConnectX was fairly minimal. We've heard about the new process, the step-by-step submission stages, and also the IFC data requirements, including the validation process, was still very largely unfamiliar to us. So upon recognizing the scale and significance of this change, we decided to approach the onboarding in a very systematic and structured manner. We started by first understanding the new RABW, followed by the IFC SG requirements, and subsequently the ConnectX submission portal. Over the past few months, we have developed our own internal standards, templates, and workflows based on both industry guidance and learning points from our pilot projects under CX so far. So moving on to our internal onboarding and implementation. A key part of our onboarding was engaging Singapore Polytechnic as our enablement partner. So unlike a typical trainer, SP actually worked closely with us, both as an external advisor and a rather strategic collaborator. Their role went beyond conducting workshops. They provided subject matter expertise in digital submissions and IFC standards. They also co-developed capabilities with us, helping CIAP shape the current workflows, tools, and SOPs that we needed. Most importantly, they were a continuous support system, ensuring our transition is structured and validated, and also aligned with the industry's evolving framework. So to drive this transformation internally as an office, we formed a dedicated ConnectX task force. This task force consisted of management, BIM managers, and representatives from both our Archi and technical departments. The role was to lead our implementation strategy and coordinate across teams and keep everyone aligned with the ConnectX objectives. Next, hand in hand, was our training and capability building, as well as the pilot project kickoff. This was a continuous journey to build technical readiness before and during the mandatory implementation period, and a pilot project and a process development that really tested and refined our internal workflows in a live project context. We continue to work closely with SP throughout stage 1 to 3, and I'll be sharing more about this in the next slide. Together with SP, our first step was to understand the start-to-end project workflow under ConnectX. So we mapped out how information flows between the architects and the technical team, as well as the authorities and the impact ConnectX has in our project lifecycle. The alignment was crucial because collaboration is truly the key driving factor for ConnectX. So to date, CIAP has 3 ongoing projects under ConnectX now, each in their own milestones. One project is actually preparing for construction gateway. Another is preparing for design gateway reply to our very first WD for that project. And lastly, we have one more project that is preparing for its first DG submission. All this occurred in the past, I would say, 8 months from the third quarter of 2025. The second step focused on digitalization upskilling, starting with RABW training. Here we learned the new ConnectX submission requirements, clarified the roles of architects versus BEAM specialists, and also practice using submission checklists for the different gateways involved. This stage gave our staff the confidence to understand not just what to submit, but how to structure our submissions correctly at each gateway. So this is one of our trainings in SP itself. Our whole office went down to understand the RABW together. In parallel, our technical team also underwent IFC training. This was highly technical and very hands-on. We understood the IFC SG mapping and validation requirements, ensuring coordination between architectural and structural models to avoid validation issue downstream. We also practiced structuring files with proper naming and reference according to the submission rules, um, down to IFC export and all the way to pre-submission validation tools. So through this, our team gained confidence in producing data that's clean, consistent, and also compliant, which is the main backbone of a successful ConnectX submission. As Hui Ping shared earlier on, for CIAP, we have an overseas team as well. So for this training, SB also helped to arrange for our overseas team for online training. So it was a hybrid. Those based in Singapore, we went down to SP as well, and here and our overseas team went through the training online. Lastly, we finally applied it to a live pilot project. And from then on, that was where we truly went hands-on and developed our process. To date now, we have developed a CIP internal ConnectX IFC SG guidebook. This guidebook applies to all projects that require an IFC model submission under ConnectX, and it is also CIP's internal working standard. It translates the external requirements into a practical internal workflow that we can follow consistently across projects developed based on our training sessions in the past few months. And most importantly, our real experience from our live pilot project that has since been submitted already. This guidebook is actually intended to cover the full end-to-end workflow from understanding the RABW all the way to submission while ensuring IFC SG compliance. So on the screen is an example of the content page in our guidebook. You'll see that the guidebook is structured into several key chapters. First, we start with an introduction, which actually explains the purpose, the scope, and how users should navigate through the guidebook, how users have to either link it back to the RABW or back to the IFC SG guidance. Next, we move on to the IFC SG framework, where we cover fundamentals such as what is IFC, why is it required under ConnectX, and how IFC SG works in the context of submission requirements. I feel like this kind of content in the guidebook is crucial because to an extent, everyone is also still trying to understand exactly what is this IFC SG and why is it relevant. From then, we then go into the IFC SG industry mapping file, which is a very critical opponent. This includes how to read the mapping file and how to interpret agency requirements and how we adopt it internally within CIP. Following that, we cover the internal submission workflow, which outlines the overall process from internal prerequisites all the way to step-by-step model setup to final submission accompanied by an action party delegated for clarity. The core of the guidebook is in getting started with IFC SG mapping and validation. I say core because it is what's new to all of us, where we provide step-by-step guidance on Revit setup, georeferencing, modeling approach, parameter mapping, IFC export, all the way to validation using external tools. We also document the iteration and coordination process, including issue tracking and collaboration between the architectural team and the technical team, as well as the submission through the ConnectX portal. So finally, we include a section on plugins and third-party extensions to support the workflow along with some useful references. This guidebook, amongst our very own internal standards that we already have, can be found within our central server, which all our staff will have access to. Is a reference for them, a structured reference throughout the start to end workflow, as long as they have any project that involves ConnectX, basically. On the next slide, at a high level, the submission workflow between Connect 2.0 and CX is actually very similar to what we are already familiar with today, down from project registration to pre-submissions, consultations, and progressing through the approval stages. So I would say operationally, it is not entirely foreign to us. However, the key difference is the introduction of a consolidated gateway submission. So while the steps may look familiar, if you take a look at the submission workflow column, the steps are actually very familiar to us. What we need to understand is that the coordination structure has fundamentally changed. This means we need to be more organized internally before submission because now one submission now affects multiple agencies at once. So in our guidebook, emphasis is placed on our internal submission workflow to prepare us for each step. For Connect beyond just ensuring code compliance, we now also comply through a process called IFC plus SG mapping. This is relatively new to the industry. It essentially translates our requirements into model-based data. So instead of just tracking drawings, we are now embedding compliance directly into the BIM model. So from our pilot project, one of our key takeaway is the importance of understanding the full end-to-end workflow and most importantly, customizing your existing office standards at every single step. So what you see on the right is a typical internal submission workflow that we've documented in our guidebook. And this is the exact process we are following and we will continue to follow for all our projects coming up. Based on this, we have a few key recommendations. First one is to be clear on roles and responsibilities across your entire project team and your project lifecycle. At project kickoff, it's important to define who is responsible for each step, not just the architects and technical, but also down to your admin and your IT even. So for example, your admin will need to ensure Copilot access is set up for everyone. Under Connect 2.0, these are things that we don't have to do. We need to ensure that our IT is also updated on the new softwares and plugins that they need to install for the whole office. And submission responsibilities need to be clearly split as well. We also implemented micro gateway submission schedules to better manage this, and we keep track of each other. So second, we create office templates and customizations where possible. So what I'm referring to is we developed several templates to streamline the process, such as a Connect onboarding checklist to ensure that the team's readiness and a submission portal registration template as well to coordinate with external consultants. We also customized the IFC SG mapping file by adding our own internal tracking columns for status and validation. This helped us monitor completeness and coordinate across the team more effectively. Third is I would recommend to update your BIM execution plan. This includes setting up your Revit models to align with the shared parameters and the IFC requirements. We enhanced our Office Revit template and included step-by-step guides in the guidebook for both new and existing projects. Because eventually, all existing projects also need to onboard onto Connect. So we need to keep the big picture in mind as we continue to adapt. There are also new requirements like Topo Solid in Revit 2024, which we've incorporated into our workflow as well. On top of that, IFC mapping introduces new steps such as parameter population and model validation, which rely highly on third-party tools and plugins. These should be clearly defined in your BEP as well. Overall, the key message is that Connect is not just a compliance exercise. It requires a structured workflow, clear responsibilities, and a strong internal standards to be able to execute this effectively. For us, the training was more than just a learning system. It was about transforming our mindset from drawing-based submissions to data-driven submissions. The step-by-step structure of the SP program, from understanding the regulations to mastering IFC plus SG standards and then walking through the entire workflow, made the transition manageable and achievable, even for a medium firm size like ours. Finally, I'd like to share a few reflections from CIAP's Connect journey. Our first key lesson is to involve the whole team from the start. Connect is not just a BIM or technical initiative. it affects everyone, architects, technical staff, management, and even your administrative teams. Everyone will play a role, and the transition is much smoother when the entire office understands the bigger picture and is part of the journey. Second is to adapt digitalization progressively. The shift to Connect X can seem quite overwhelming at first, but when broken down into manageable steps, understanding the new submission process, learning IFC mapping, and mastering the validation tools, it becomes much more approachable. Leverage on the tools that the industry is developing, and they will continue to develop these tools because we will only continue to advance from here. So, what I would suggest is continue to expose yourself to all the third party extensions that's currently being, I would say, competitively developed right now. Lastly, set up your standards, stress test your workflows, and also train your teams. By the time Connect X becomes mandatory for all projects, you will have the systems, the knowledge, and confidence in place. Yeah, that's all. Thank you. Now I'll pass the sharing back to Hui Ping.
So to conclude, SP is committed to helping the industry to transform the workforce, especially in terms of digitalization. So by embarking on this collaboration with CIAP, we were able to help them to diagnose their training gaps and needs, and then identify the right solution pathway for them. Eventually, we also hope to implement and sustain the change long term. So lastly, these are some of the training that DBIC has conducted. So in SP, we are committed to driving company and workforce transformation. This applies across various departments in our school, not just DBIC, where we have industry coming in to check with us on their training gaps and needs. So we help to build the awareness to discover the needs. From there, we identify the right solution and then help to implement the change within the firms. So in the last slide, so this is what DBIC Digital Building Innovation Center has worked on in the past. So we leverage technology to assist businesses in enhancing collaboration, productivity, and innovation. We also want to increase awareness of BIM among like-minded individuals and companies. So we hope that what we are offering here is able to help firms adopt digital transformation. And lastly, if you'd like to find out more about the training schemes or grants that are available, you can scan this QR code to find out more, and then you can write to us. Yeah, thank you. That's the end of our sharing.
Thank you. Thank you, Jackie and Hui Ping. Maybe we give the attendees some time to scan the QR code before we jump into Q&A. We actually have two questions here. So first one, with Connect X requiring unprecedented multidisciplinary collaboration, how can collaborative contracting frameworks be structured to fairly allocate risk and intellectual property ownership when co-developing or deploying novel DBIC digital workflow? My understanding is that these questions falls outside the official training scope. But will Miss Jackie like to share a little bit with her perspective on this?
So, in my opinion, that is actually a great question because it touches on one of the most significant yet under-discussed aspect of the industry's shift towards digitalization. Much of the current conversation around Connect X has understandably focused on technical requirements. However, a less visible but important issue is our multidisciplinary collaborative framework. So, in my view, collaborative contracting framework should address three key principles. So the first one is on risk. So risk should continue to be allocated according to each party's scope of responsibility, building on the structure that is actually already embedded within Connect X. The requirements and the submission process is linked to the party responsible for authoring and certifying this information. This means that accountability remains aligned with each consultant's sphere of control, rather than being transferred entirely to the single lead consultant, meaning to say the Archi QP actually, because the RKQP is the last one to make the overall final submission. But in many ways, the current framework itself already provides a fair foundation for allocating all these technical responsibilities. Next one is on the intellectual property ownership. It should continue to distinguish between project-specific deliverables and reusable digital tools. So what I'm trying to refer to is project-specific deliverables are our submission models and project data. These should continue to belong to the client and consultants, but reusable assets such as our internal office templates, validation rule libraries, IFC mapping standards, and automation tools should remain the intellectual property of the consultants who develop them with all the appropriate licensing granted for the project use. Um, Reusable assets will continue to differ subjective to each firm's internal workflow and the development, but ultimately it will lead to the same project-specific deliverables, which is on the whole team really, including our client and our whole MDT. Lastly, I feel that digital coordination and data governance should soon be recognized as a dedicated professional service because the additional activities such as IFC mapping, model validation, and digital compliance coordination all require significant effort and it should be clearly defined and adequately recognized. So ultimately, Connect X is not just about transforming how we submit to all our agencies, it is actually reshaping how consultants collaborate as well and how we share accountability and also and protect our digital assets that we are using in order to do our project deliverables. So in short, our contractor agreements, right, our BIM execution plans have to be relooked and reshaped to also adapt to this shift. The firms and clients that address these issues proactively will be better positioned to realize the full benefits of digital delivery while maintaining fairness and also continue to encourage the innovation.
Thank you so much for your answer. I think there's a question that is addressed to you. Will geospatial or GIS be implementing along with BIM and optional or mandatory?
Sorry, may I know the question again?
Will GIS be implementing along with BIM optional or mandatory?
May I understand what is GIS?
I think it's the location tracking, right? So,
PLS,
Mr. Qureshi, your
government sales or
I,
GIS?
this question it seems to be asking along the line of compliance, is it? Whether it's mandatory for this GIS to be implemented together with BIM. In this aspect, we won't be able to answer because whatever we need to comply, we comply. Whether it's made mandatory or optional, I'm afraid we cannot answer that. And your second question on how SP provides support to GIS companies working in AEC industry towards IDD and digital transformation. As of now, for DBIC, we have yet to work with any GIS company. So to answer this, how we can support, if you are interested, any GIS company is interested, please reach out to us because only when we work with such companies, we are able to diagnose your needs and then be able to answer how we can help towards IDD and digital transformation. Because one thing to know about our training schemes is that we do not give one solution for all companies. Usually we go through this process of understanding the company's workflow operation, diagnosing your needs, and then we are able to customize a solution. So for question 2, I'm sorry, I cannot answer how to provide support. So if you are keen, please reach out to SP. Yeah.
Thank you. Thank you, Hui Ping. Thank you, Jackie. Thank you so much for your delivery. Moving along, we'll welcome the next group of speakers, a team of experts from Singapore Poly's Advanced Materials Technology Centre. We have with us from the Advanced Materials Technology Centre will be Mr. Thomas Goh. He's a lead research engineer at Singapore Poly Advanced Materials Technology Centre. His work focuses on sustainable materials innovation and circular economy solutions for the built environment sector. So for this webinar, Thomas will present on turning battery waste into sustainable concrete, showcasing how waste material can be transformed into practical low-carbon construction solutions that support sustainability goals and resource optimization. And with him is two of his colleagues as well, Ms. Troya Muthusamy, who is the lead material scientist specializing in sustainable material development and low carbon construction innovations. Her webinar presentation will be on sustainable low embodied carbon construction models using biochars. We'll explore how biochar-based materials can contribute to reducing embodied carbon in construction while supporting more sustainable building practices. And lastly, they will be joined by Ms. Esti Tan, Lead Research Engineer, with expertise in materials engineering and sustainable building technologies. For her part on the webinar, Esti will present on solar heat rejection coating transforms glass performance, sharing how innovative coating technologies can improve energy efficiency and thermal performance in buildings. So just to do another housekeeping, if you have any questions along the way, please feel free to drop them in the Q&A portion. So let me pass the screen back to Mr. Thomas.
Thank you, Isabel, for the kind introduction. My name is Thomas, and I'm the lead research engineer from Singapore Polytechnic. So my background is actually on the industry chemistry over the past few years. And my interest is more on how to turn sustainable waste to make it into useful product so as to promote the circular economy. So our team here is from the Singapore Polytechnic Advanced Material Technology Center, and we work with various industry partners as well as the government agencies on several projects which is more industrial relevant and industrial ready solution. So the role in AMTC here is actually try to bridge the industry gap with the problem statement that is provided by the industry. And one of the most important thing here is that most people within the built environment industry, people would have known that the cement is actually one of the highest carbon dioxide emission globally, contributing up to 8% in the cement production. And within Singapore, the concrete upstream emission is actually up to 6% at the national level because of the demand in consistent building and demolition in the new buildings as well. And our solution here is to actually use upcycling waste to create concrete. And the reason behind this is that because when we are using the waste material to create concrete, we are actually fulfilling 4 out of the 7 United Nations SDG goals. Most importantly, the most important goal here is the SDG number 12, which is the responsible consumption and production. So this deals with the how manufacturer actually use the raw material as well as how they treat the waste material at the end of life. And not only this, SDG 9 also fulfill the innovation portion where we use waste material to create more innovative product. And SDG 11, we also create a sustainable city with our sustainable material with the new concrete. And lastly, SDG 13, the climate action. So in this portion, we actually try to reduce the carbon emission by lessening the use of raw material and also lessening the land filling portion in the Pulau Semakau land in Singapore. So thereby, we actually fulfill 4 out of the SDG goal by creating a sustainable concrete mix. Then secondly, I'm going to talk more about the graphite here because there's a push in the electric vehicles all around the world globally. And most of the EV manufacturer actually try to guarantee that the EV battery is supposed to last around 8 to 10 years or up to 100,000 miles. And with the condition that this battery must able to retain 70 to 80% of the original capacity. So if it's below 70% of the battery capacity, then it will not be suitable to continue to use this battery for the electric vehicles. And so because of this, we're actually expecting a large amount of the battery will be decommissioning in the upcoming years. And secondly, following the Singapore Green Plan 2030, the Singapore actually government is committed to phase out the internal combustion engine, which is our current petrol car engine by 2030, with the push to full EV or a hybrid EV vehicle by 2030, and for all the vehicles, including the buses and lorries by 2040. So what is the innovation that the SPAMTC is providing here? So in the traditional concrete mix, you have the Portland cement, which is a high carbon footprint, as well as the use of the natural river sand, which is what commonly used today. And for our SP sustainable mix, the one that we have currently, we are actually using two different types of supplementary cementitious material, which are the material that can partially replace cement. So one is the GGBS. So GGBS is actually an established byproduct from the steel production. And secondly is the spent graphite. So spent graphite is our main focus here because it is the innovative and upcoming waste material that will be coming in large volume in the upcoming years. And if you ask me like how much graphite can you obtain from the battery, so depending on the battery manufacturer, the amount of the graphite can account from about 12% to 21 weight percent by weight per vehicle of the electric vehicle battery. And this graphite is used in electric vehicle in battery because of the high electrical conductivity in conducting the electrons to make the battery work efficiently. So when you actually put the spent graphite into concrete, right, we are actually expecting that this concrete can open the doors for energy efficient, smart infrastructure, as well as the smart building application. And secondly, in the second portion, we are also partially replacing or fully replacing the river sand with the manufactured sand. So this manufactured sand come from the granite quarries. And because they are manufactured, you can actually control the size to be cubical. And because they are all more or less controlled under a tight stringent condition, this manufactured sand actually give the concrete to have a more consistent workability as well as the consistency. So we want to promote the use of the graphite as the one of the SCM to eliminate the waste disposal cost for the waste recycler. And we also create a new product revenue for this waste recycler and reduce the demand for the carbon intensive cement. So we're actually hitting we're killing three birds with one stone. Okay, so under this zero waste system, right? How it works is that first, from the battery supplier point of view, there will be an extensive extraction and purification of the battery. So this is to actually decommission the battery to prevent like battery explosion. So they have to treat it first. They have to fully discharge the battery first, for example, in a concentrated salt solution to prevent the explosion. Then after that, they will dismantle it. Then after that, they will separate the respective metal component, plastic component. Then subsequently, they will extract the lithium, the heavy metals, and lastly, the graphite. So usually the carbon, the graphite carbon and the heavy metal will come together as what we call it as a black mass. Then from there, you go through a further purification, which is step number 2, which try to separate the metals from the respective compound. The reason is because for battery manufacturer, they want to sell the material back to the raw material supplier. So they want to separate this lithium to sell as lithium, or they can sell the iron, the nickel, the cobalt, and not forgetting the graphite. So graphite for them is probably the least important because of the lower value as compared to the other metal. Yeah. Then thirdly, after we separate the respective element, we can formulate this graphite into in combination with GGBS and our manufactured sand to create a ternary concrete mix. And with this optimized formulation, it has a potential to be used as a smart road and durable buildings and the next generation urban infrastructure. So to give you a graphical point of view, you can actually see that in this concrete mix, there are two kinds of SCM, which is the graphite particles and the GGBS. So with the interlocking of these particles together with the cement binder, you can actually create a more durable and more consistent concrete mix. Then secondly, with the incorporation of graphite, you actually improve the electrical conductivity of the concrete. And this can actually serve as the value added for smart infrastructure or sensor integrated road. But this has to be optimized with the percentage of graphite that can be incorporated into this concrete. So the more you add, the more graphite is inside the concrete, the more conductivity will be performed by the concrete. Yeah. Then the third one is the end sand. So with the cubicle seal of the manufactured sand, you actually improve the workability and have a more consistent mix. And with these three different this sustainable raw material in mind, you create a lower embodied carbon concrete. Okay, so now we'll talk about the performance, because performance is the most important matrix for the industry. So following the BS standards, we can actually achieve an ultimate strength of 60 megapascal, which is far greater than the grade 40 concrete requirement. So this enhances the suitability for structural concrete application. Then also, we also send this our concrete to a third party accredited laboratory to measure the toxicity test to in compliance with the NEA standards, which is the US EPA 1311. So you can see that our concrete actually passed all the performance with very negligible amount of the heavy metal. And not shown in this picture, it also passed, for example, the silver, the cadmium, chromium, and also phenolic compounds, cyanide, and also fluoride. So a side-by-side table comparison here, you can see that our SP sustainable concrete mix, when compared to the traditional concrete, you can have up to 55% reduction. So this 55% reduction, I have to clarify here, is the one that we show for the concrete mix that is sent out to the accredited laboratory. And of course, this carbon footprint can be adjustable according to how much graphite and how much GGBS or M-sand is added into the mix. So this is just for reference with respect to the previous two slides. Yeah. And as for the cost, we put here similar or lower, because at this moment, we are not sure how the battery recycler are going to price their spent graphite, but we are quite sure that GGBS is also slightly cheaper than OPC cement. Then for the last performance, you can see that we also improve the ultimate strength of 60 megapascal with the enhanced electrical property. So our value proposition here is that not only we can have a carbon dioxide reduction of more, up to 55% reduction, we also enhance the electrical productivity of the concrete. And the last part is that we also provide customizable mixes under the Singapore Polytechnic. So because we know that this concrete mix is not a one size fit all, so we actually cater to the company's demand for actually what kind of workability or the carbon target, or even the budgeting or the conductivity performance for us to tailor to the specific need for the required concrete product. So in terms of the real world possibility, right? At this moment, our technologies have a TRL level of 5 after passing the third-party accredited laboratory test under real-life condition. The main immediate use here, I would say here, is the durable construction. Because Singapore climate and the heavy traffic require material that can resist the environmental stresses. Therefore, we actually try to incorporate a combination of GGBS as well as the spent graphite to create such innovative and durable concrete here. We also want to leverage on the unique electrical conductivity of the graphite to create an energy efficient and also even a sensor-ready base layer. It could be below the building or even below the roads. So our recent technology is published in the SGBC website. So if those are interested, you can feel free to visit and read more about it over there. So in conclusion, right, this construction is actually not only about building, it's also about closing the loop and connecting the waste recycler with the producer. So right now, in SPAMTC, we try to be the industry bridge. So we are looking for example, for test bedding, the ready-mix concrete companies, the urban planner government agencies, and also the contractor who are ready to deploy such a customizable mix. And second, we also can provide direct licensing based on the concrete performance that you saw in the previous two slides. And also we invite R&D collaboration with more battery recyclers and sustainable researchers who want to find out more about how they can further purify and make this concrete. to suit the suitability of the desired material property. So this technology has been proven, and then the environmental imperative is clear. So we hope that most people here can take action today. So whether you are the ready-mix concrete company or the government agency or contractor, or the battery recycler, or even the researcher here, we welcome all kind of collaboration and invitation. So this is my last slide, and thank you very much. And below is my team. Yeah. So with this in mind, I would like to please feel free to ask any question in the chat box. And with this, I will hand over to the next speaker, Ms. Rabia.
Good morning, good afternoon, whichever time zone you're joining us today from. I'm Dravya, lead material scientist at Singapore Poly's Advanced Material Technology Center. We've seen a lot about sustainable materials and its use and its need in today's requirement. And what I would be addressing on is what can be done beyond that? What can be done beyond the use of these? Can we go down to a lower embodied construction materials? What we've done the test is in mortars using a material called biochar. So looking into that, if we look around us with the constant urbanization, there is no doubt cement is being used all around us, or at least it's around us everywhere, right? With much has been said already on it's contributing 8% of global emissions and a sector which is actually contributing up to 34%, right? Keeping these numbers high, we can do the math to say that when 1 kg of the cement is produced, 0.9 kgs of CO2 is emitted. When I started from this industry, the values were much higher than this, and it has really significantly come down, yet there is need to do much more. On the flip side of things, if we were to see, we can also see there's close to 600,000 tons of waste, especially wood and horticulture waste, which is being produced in Singapore. As for the NEA record from 2023, we have seen those numbers. And we see there is a slight potential in this, in upscaling this to make into components which can later be used for other applications. But very importantly, what we see is what is important is there is a need for a mind shift change. We need to ensure that we have a material level mind shift because that is the core foundation of all the buildings that you see around us. So when we do that right, we will end up at a carbon negative as we go on because the foundation has to be right. And that's what at SP we would like to address. In SP, we've always tried to use sustainable materials. We've tried to use recycled materials. And now we are going down beyond to see, can we use carbon negative materials, which can then later help us in reducing the emission values, not just by number, but actually contributing as negative materials to further reduce the contribution coming from other materials, which was used initially from there. And biochar, through its pyrolysis process, actually has this potential of doing what other materials can't, which is carbon sequestration throughout its life cycle. We talked to a lot of local suppliers, and one biochar local supplier whom we had contacted had 3 distinct sources of biochar. We tried to address them. We tried to study them to see if it's usable directly. And it was rice husk, wood waste, and plastic waste. In general, what is usually done for mortars is that it has cement content. And no doubt it has a very high carbon emission number. Traditionally, we look at SEMs. We try to reduce the amount of cement that is used there so that because these SEMs have a much lower carbon emitting number. Now we are going beyond that. Can we use materials that can contribute or contributes much lesser than just the use of SEMs? Can we use biochar? Because biochar, especially the biochars coming from the biomass sources, have sequestration potential, making it a carbon negative material for use. And that what helps us a lot of other Singapore goals that has been set in the market. Completely in line with Singapore's 2030 vision, where we need to reduce the waste that's going to the landfill by 30%, right? And that is something that we need to really work it out. And in addition to that, there is a really long-term plan that Singapore has to make Singapore zero waste vision. So that's a complete long-term plan because every step that we take in this direction counts because zero waste is a dream that we aim to achieve. And Singapore's Green Building Master Plan 2030, not far away from where we are speaking to each other today, is that we need to achieve. There are three distinct sectors of 80-80-80. One clear sector on this is the 80% of the building's gross floor area has to incorporate green materials or sustainable materials. And that's going to be a mandate for them to achieve this. Not everybody is working towards biochar. There is no doubt that biochar is helping in a lot of other things that's happening around. There's initiatives that's coming from Europe, US, the Asia Pacific market is not far behind. Everybody's working on that. And completely in line to all these adaptations, which is happening across the globe, Singapore has also come up with its code of practice. Code of practice for helping industries to envision how can biochar be incorporated. What is currently used is in the agriculture sector. Can that be also incorporated into construction sector? Construction sector seems to be the sector which is trying to absorb in a lot more than what it's actually contributing to. But then that's what the COP is all about. It gives you a detailed explanation about how can things be incorporated and what are the requirements there listed down. At SB, when we did this study, our idea was to speak to the supplier and get their raw biochar sources and understand if the biochar sources that we have in the market today, which is being sold, are they directly usable? Meaning to say that once it comes out of the pyrolysis process, can we directly use them into the applications for the building sector that we want to reduce? What we had found out was there is a need for a pre-treatment because they in itself are directly not usable for a form that we intend to use, especially if you want looking at cementitious material replacement. If you're looking in that direction, there is a need for a pre-treatment. So what we had done is we have done the required pre-treatment, keeping in mind that we do not want to add in more emission numbers during this pre-treatment process. That is vital. The idea is that the ultimate product has to be greener and sustainable. It can't have a pre-treatment or any kind of processes which is going to add on to this number from whatever good that the biochar is doing in itself. And with that, we ensure that when the adaptation comes in from the construction sector and the construction sector wants to adapt these, there is a need for material testing. So we had done all the required material testing for this to be used as a material additive, and also send these to third-party laboratories to ensure that the values are not just from what we had done in the lab, but also accredited by third-party laboratories, verifying these results and to ensure that they are usable immediately by anyone who's interested in it too. We have seen this, basic, all the essential properties like setting time, soundness, consistency, chemical compositions have all met the required standard limitations. Loss of ignition was something that was brought up when we had given the study, because especially materials like biochar, which usually comes in after a pyrolysis process or a burning process at a low, there is sometimes potential that there has been still components which might have ignition properties. So there has to be a test done on this. So that was also conducted, and we ensured and we did optimize property mixes to ensure that these values are also in line to what the building environment sector needs and is essential. And strength is something we all love to see. That does that help me to improve a strength? Yes, it did to a certain extent, but it completely depends on the type of biochar that you're trying to incorporate, the application where you intend to use it, or it also depends on the composition mix that works best for you for your application. There is, but it depends on the application of use. So just don't have to rely on cement in itself. But I think we also try to do rigorous testing to make sure that other materials which has potentials could be used as replacers. One concern that we have experienced is from the industry is that the environmental concerns. No matter how much we want to use these waste materials, there is always concern in terms of its toxicity characteristic testing, the leaching properties, especially in Singapore, when we are trying to collect much of the rainwater. We do not want these buildings, which is covering most of our spaces here, has any of these which is going to leach out components which might affect our drinking water. Keeping that in mind, we did the complete study on leaching analysis for all the 3 different types of biochar and also in combination, and they seem to be doing quite fairly well in terms of its safety standards. They are much lower in value. That means they are completely safe for use from the tests that we have conducted in the laboratory. What was interesting for its use is that these materials as biochar does not really require much advanced technologies or some advanced equipments in your current situation that you have, whether they are concrete suppliers, mortars, precasters, or premixed mortar. It has applications that can be widely used across the industry, because as wherever you can think of cement is where it can actually adopt itself with a little bit of tweaking to make sure that you get the performance that you need. It has complete versatile adaptability that is there without much incorporation of new things inside your operational space. And that is an add-on and a complete add-on to what we can do. And there's a value proposition for this having a TRL5, which is when the code of practice in Singapore already states on its usage and technically gives you a complete guideline to say that how can these be used, not just for agriculture sector, which is currently in place, but also for the construction sector and also for water purification sectors. It gives you a complete guideline. So this is already in the code of practice, the use of biochar. Additionally, in the June of last year, there was also an e-resource that was released out by BCA. So if you're interested to know that how do I now incorporate biochar, what are the tests that I need to still ensure that the industry can adopt, I think there is a clear guideline. There's a flow chart which they have actually put up, BCA has put up with a lot of industry sharings as to how exactly the step that has to be taken to make sure that your any new adopting technology can go out to the market and be tested. So biochar was one of the case study taken in and given a complete detailed analysis on how you can adopt it. Please do have a look into that. All our tests, and additionally, whatever tests we have done, completely has passed the accredited testings. We have verified these values, so it is completely safe for you to go ahead and use them. And, environmental safety or leaching standards have also been taken care of, so you don't have to worry about the NEA or PUB's requirements for use of this material and your building constructions. What we have seen now is that the material can be seamlessly integrated into any of your adaptations without any advanced equipments or technologies or adding in new machineries to your pipeline, because much of this is very similar to the cementitious use, and all the industry adopted has silos which can then be used to add in. And with that, I would like to say that we are open to work with anyone who wants to license this product directly with us, or any new product developers, like ready-mix concrete suppliers, producers, or blended cement manufacturers who are interested to see how this can be modified further, or anybody has contractors have test bedding locations where we can actually test try them in real life applications. We'll be happy to do that. And last but not least, to recyclers, but not just for biochars, for these 3 different types that we have studied, we are also open to study biochar properties across other biochar sources, incoming sources, and to see what proportion works best for them and how can they add value proposition to an industry like this. With that, I would just like to say thank you for joining us today. And you can always drop in at Singapore Poly or write into us if you have any further details, because what we believe is that every step counts, and hope we all work together in this carbon negative future together. Thank you. I would like to now pass it on to Miss Esty.
Good afternoon, everyone. I'm Esty from Singapore Polytechnic's Advanced Materials Technology Centre. Today, I'll be walking you through a solar heat rejection coating we have developed for window glass, what it is, how it works, and what the real-world data shows. Let's start with the problem. The glass buildings are everywhere, and they have come to define the modern skyline. But in a tropical climate like Singapore's, that glazing comes at a cost. Up to 40% of a building's cooling load comes through its windows. Solar heat gains drives up cooling demand and energy costs significantly. The challenge then is to block out the heat without losing the natural light that makes glass facades desirable in the first place. So how does our solar heat rejection coating work? Sunlight is made up of visible light, what we see, and infrared radiation, what we feel as heat. The coating is engineered to let the visible light through while blocking the infrared before it enters the building. It is spray applied at just 40 to 50 microns thin, and it blocks 99.8% of infrared radiation, while still allowing 46% of natural light to pass through. So it's just a filter for heat. The light gets in, but most of the heat stays out. So overall, the total solar energy rejection is 81%. These are the third-party laboratory testing results, tested to ISO 9050 standards. We have also included a benchmark comparison against the market-available window film. First, just to note on why we are comparing these two products. The visible light transmittance is comparable at 50% for the market film versus 46% for our coating. It means that we are comparing two products that let in through a similar amount of natural light. Now, let's look at the solar heat gain coefficient, or SHGC for short. Imagine standing behind a window on a sunny day. Some of that solar heat is reflected by the glass, some of it passes straight through, and some of it gets absorbed by the glass and is re-radiated. SHGC measures how much of that total heat actually ends up inside your building. So the lower the number, the better the coating is at keeping heat out. The market film brings the SHGC down from 0.89 to 0.44, but the solar control coating goes even further to 0.39. So this means that at a comparable level of visible light transmittance, our solar control coating delivers better heat rejection. Laboratory results are important, but we also have validated the coating under actual Singapore weather conditions at BCA Skylab. The setup was two identical side-by-side rooms, same temperature set point, same lighting, and the same simulated occupants. Both rooms face west, meaning they took on the full force of the afternoon sun. The only difference was the glazing. One room had the solar control coating applied, and one room did not. Because the conditions were identical in every other way, any difference in performance between the two rooms can be attributed directly to the coating. Now for the energy performance. Across the test period of 8 days, the coated glazing delivered an average daily cooling load saving of 8.85%. And when you look at total energy, which includes lighting, fans, and plug loads, as well as cooling, the saving is 3.41%. This means that for a building owner, this translates directly into lower utility bills and a lower carbon footprint. Besides energy performance, occupant comfort is also important, and the solar control coating performs well in this area too. On thermal comfort, it was measured using an internationally recognized scale called the Predicted Mean Vote, or PMV. A score of 0 means that people feel perfectly comfortable, and the further you move from 0 in either direction, the more uncomfortable people feel. So the accepted range for good thermal comfort is between negative 0.5 to 0.5. And the coated room stayed within the comfortable range 98.1% of the time. On visual comfort, the coating delivered a 33% improvement in imperceptible glare. This means that 87% of the time, glare in the coated room was at an imperceptible level, compared to just 54% in the reference room. This means that occupants can keep their blinds open and still work comfortably. Beyond glare, we also look at the quality of the light passing through the coated glass. The first metric is daylight quality, whether the combination of light levels and color temperature feels pleasant to the people inside. We assess this using the Koitov curve, which maps out the characteristics of light that humans find visually comfortable. So the light passing through the coated glass falls within the pleasing range. The second metric is the color rendering index, or CRI for short. In simple terms, CRI measures how accurately a light source reveals the true colors of objects compared to natural daylight. For building owners, A practical way to think about it is this. If you apply this coating to your windows, how will it affect the way colors look inside your building? A CRI above 80 is considered good quality lighting, and our coating had a CRI of 89. This means that occupants will still perceive colors accurately and naturally. The coating doesn't cast a tint or distort the indoor environment. So in short, the coating reduces heat and glare without compromising the quality of the indoor visual environment. In summary, the coating delivered positive results across energy, thermal comfort, and light quality. On energy, the coating delivered a cooling load reduction of 8.85% and total energy saving of 3.41%, both measured under real-world conditions at BCA Skylab. On visual comfort, daylight glare probability results showed a 33% improvement in imperceptible glare, meaning occupants are far less likely to experience disruptive glare from the afternoon sun. And on the light quality, the color rendering index came in at 89, well within the good range, and comparable to what you get through uncoated window glass. So taken together, this is a coating that reduces heat and glare while preserving a high-quality indoor environment. So you may wonder how this compares to conventional solar films. The key difference comes down to how the coating bonds to the glass. Conventional films rely on adhesive, which tends to peel or delamine over time along the edges, especially when moisture gets in during routine window cleaning. So our coating forms a continuous layer bonded to the glass surface, eliminating those failure points and reducing maintenance requirements. And because it's spray applied, it can go onto curved surfaces, complex facade geometries where conventional films cannot be used. Finally, the spray-on application makes this a practical, low-disruption retrofit option for existing buildings, for cooling energy savings and glare reduction without replacing a single pane of glass in your building. For building owners who are working towards green mark certification, the coating is worth considering as part of your energy efficiency strategy. So if today's results have piqued your interest, here's how you can take this further. For companies who want to see the coating perform on their own building before committing, we can work together on the trial run, a chance to validate the performance of the coating in your specific context with your own glazing system under your real operating conditions. And for those who are ready to take it further, the technology is available for commercialization through Singapore Polytechnic. Whether you're a glazing contractor, a building products company, or a sustainability solutions provider, we'd love to share more about technology and explore collaboration opportunities. If either of those pathways sounds interesting, please do reach out to us. Yeah. Thank you very much for your time today.
Thank you, Miss ST. Let us jump to the Q&A. We have a few questions actually for the three speakers. First question that we have is addressed to Mr. Thomas. Mr. Thomas, what are your views on the future trends of EV car batteries in Singapore?
Hi, thanks Isabel for the question. Yeah. So if you look around the Singapore car park today, it's quite clear that the electrification is already around us, with the charging point around the car park, a multi-story car park, and even in the private spaces. So many of us living in Singapore are already planning for our next car to be either a full electric vehicles or like a hybrid EV by 2030 due to the Singapore Green Plan push lah. Yeah. So over the next decades, not only in Singapore, we see that the whole world is going to have a massive ways of decommission electric vehicles. So the thing about scientists is that before we even try to work on the batteries and the electric vehicles, some of us already think about the aftermath. So what are we going to do with these decommissioned electric vehicles? So in reality, right? So first of all, a portion of this decommissioned battery actually do have a second life. So for example, they can reuse the battery. They are no longer serving the 70% capacity. We can also use them in the secondary energy storage system, ESS. So for like the grid storage as deployed by if I'm not wrong, it's JTC and the EMA authority in the industrial estate. And secondly, when a battery really reaches the end of life, we need a commercial scale battery recycling facilities. So they are already in the news. Our Singapore government actually supported a few of the e-waste facilities, for example, the SK Test, or previously known as Test M, and even the KGS, who invited the minister to their opening ceremony to actually establish a dedicated recycling plants. So in AMTC ourselves, we take the residual material that cannot be reused or sold at a higher value, or those that cannot be purified into higher battery grade materials. We'll take those lower grade materials and try to repurpose it to meet the industry requirement, so that we want to ensure that it doesn't end up in the Pulau Semakau landfill. Yeah.
Yeah. Okay. Since you mentioned the EV batteries must be broken down before it can be used in sustainable concrete, how extensive and resource intensive is the extraction process, and how does the cost of this recovery compare to using other recyclable that is already available in the concrete production?
Okay, that's a quite a technical question. Okay, so let's be honest. So for a battery recycler point of view, the extraction and pre-treatment process is a very technical process. It require a very stringent safety and environmental control, because when we are dealing with battery, there's a lot of incidents that the power bank explode in the plane and everywhere, right? So for recycling themselves, they have to take care of this very, very seriously. So some people will ask what is the estimated cost for the battery recovery? And from the company point of view, they also ask what is the cost of the spent graphite if they were to put it in the concrete itself? To be honest, the battery recovery process are actually proprietary to the individual waste recycler. So even though there are known technology available for how battery recycler can use, but the ultimate how they treat the battery to have a higher purity of lithium, higher purity of iron, manganese, and cobalt is actually very confidential. And also for the it also depends on the material volume and market demand as well. So for the electric vehicle, for example, lithium-ion battery, the amount of graphite is about 12 to 21%, and this economic will differ from country to country. So for example, a big player like China, who manufacture a lot of electric vehicles, they probably can process the battery waste at a much lower cost as compared to, for example, Singapore, because of the scale as well. So, but here's the thing, that this processing step for the battery recycling is already a non-negotiable requirement. So die or not, they have to treat it and process it. And as to how much they can cost, we are unable to advise. Yeah. But what AMTC can do is that we can create, based on the low cost waste material, AMTC can help to create a new sales channel and revenue for the waste recycler. And instead of paying to dispose of this industrial waste, so why not we ask the battery recycler to process the waste a little bit more, so that they can generate new sales for the company and even reduce the carbon footprint.
Okay. Are these innovations currently adopted in the industry? And what do you think is the current gap that the solution solve other than the ESG side? Yeah.
So we are currently moving from the accredited laboratory validation TRL5 to the actual pilot plant, and hopefully eventually to the industrial adoption. So besides taking the ESG compliance checkbox, there are some solutions that can be solved massively in the operational gap. So for example, in the regulatory point of view, the government agency, through the BCA and the HDB, our Singapore government is actually actively pushing for lower embodied carbon threshold for public housing and even the infrastructure, and even in the coming, for example, reparation work. So even the reparation work, some of these requirements indicate to have a sustainable element in it. Yeah. So when the companies are tendering for the project, so adopting this kind of low carbon concrete is no longer just a bonus, but it's actually going to be a requirement in the future. It's going to be more and more stringent.
Okay.
And then in terms of the resource reliance, right? So by utilizing the Singapore localized waste, we actually help to directly reduce the carbon footprint in terms of the A2 transportation. So we want to cut down on this embodied carbon or A2 in the life cycle assessment when we are calculating the carbon footprint of the product. And not only that, in the Singapore food waste source, it also helps the Singapore industry to shield from the supply chain in terms of the volatile raw material cost and aggregate supply disruption. So we feel that Singapore reputation and building standards are already recognized globally. So it actually helped to validate this material in Singapore, help our local Singapore partner to expand into the overseas market, which means that if you have a locally certified concrete in Singapore, most likely you can sell in other parts of the world as well.
Oh, okay. Thank you so much.
Yeah, thank you.
Next question we have is actually addressed to Miss Troya. Miss Troya, we have a question from one of the attendees is, where are we on target to meet sustainability goals?
Wow, wouldn't you know that? Yes, I mean, definitely Singapore has set up, like I mentioned, the net zero emission target by 2050, and not 2030, as some of the other targets go in. But it's very important to know that this is a long-term plan that needs to be addressed. And I think all the agencies are working together with it, whether we are planting trees or if you look around the housing that you're staying in, there is solar rooftops, which we adaptations going on. There is rebuilding master plan with the 80%. Much has been said to this, but I think if you go down to tangible numbers to see like what exactly are the numbers now and how far away are we from reality, check. What was interesting to see in the December of 2025, that is just last December, the green building
Oh, I think she might have some connection hang.
and then what we can do beyond that. I'm sorry, was I not audible earlier? Okay,
Yeah.
MP target status was released out in the December of 2025, where actually they had actually released the numbers to see whether what are the actual status now in comparison to where we stand in. So by going by 2025 numbers in December, it was seen the first phase of the 80%, which is stepping into the phase of greenery around the buildings. By 2030, we are around 66% has been achieved out of the 80% that was the target values. And what has been done very well is on the improvement in the energy efficiency part of the buildings. You know, that has the best in class energy efficiencies that we could add in by 2030. Current numbers that was released in December was 72% out of the 80% that is needed. And where we need to do a lot of work is probably on the use of new developments to use the gross floor area into sustainable materials. And that's where pretty much what we are speaking of today right now with SEMs, biochars, or battery waste, or whatever best we can do, whatever little step we can do, because the numbers seems to be only at 33% at this point of time as per the December values. And there's a gap that needs to be addressed and has to be covered up in the next few years, because 2030 is not quite far away from where we are. And I think that widespread adaptation for these low carbon materials becomes absolutely important, and probably with digitization and other techniques could help into rapidly help them to adopt these technologies. And it's good to see that when BCA comes up with these e-resources, they give you an opportunity to understand what is needed and how can these adaptations be taken care of, because it clearly steps down the process to do so. Yeah.
Thank you so much for your answer. We have another two questions and we still have a bit of time. The two questions is addressed to Miss ST. Miss ST, the first question our attendee have is regarding solar heat rejection coating. Will the surrounding buildings be affected by this heat rejection? Where does the rejected heat go to?
Okay. So the short answer is that no, the coating does not redirect heat to the neighboring buildings. Yeah.
So if let's say there's a tree next to the tree will not be affected by it.
Yeah. So according to the laboratory measurements, the coated window glass has an outdoor solar energy reflectance of 5%. And for reference, the uncoated window glass has a reflectance of 8%, so it's quite comparable. So this coating is different from mirror-like facades. The coating does not create a kind of concentrated glare or heat redirection that would affect the surrounding environment.
Okay. Next question we have is how significant is the actual energy saving potential of solar heat rejection coatings in tropical climates like Malaysia and Singapore?
So for tropical climates, the savings are significant because we experience very intense solar heat radiation almost all year round. Yeah. Unlike temperate climates where during winter the solar heat gain is not really a concern, here in Singapore and Malaysia, it's a daily driver of cooling demand. So our BCA Scarlet trial showed that under Singapore conditions, there was an average daily saving for cooling load of 8.85%. And the savings are not just once, it happens every day. So when you compound the cooling energy savings day after day for a whole building over years, it adds up to a significant reduction in cooling energy consumption and operating costs.
Thank you so much. I think that comes to the end of the Q&A. So on behalf of the speakers and myself, ladies and gentlemen, thank you for joining us today. And a very big thank you to our speakers for sharing their expertise. So before we sign off, just a quick heads up, BEX Asia registration is officially open. So do log in your attendance early. And also as mentioned, mark your calendars because IBW ticketing is going live next week. So in the meantime, do follow our LinkedIn page to catch the launch news and grab the early birds promotion. Don't just come alone, bring your whole team along. We will see you at IBW and BEX Asia in September. Thank you. Bye.